Competitor number 9 is Mustafa Ghazi, a mechanical engineering PhD student, whose presentation is entitled 3D Motion Capture Using 2D Markers.
"17 million people around the world have a medical condition called cerebral palsy. Children born with cerebral palsy have difficulty in controlling their muscles. It can take years of therapy before they can learn how to crawl and then walk. Currently, children with cerebral palsy need to visit healthcare facilities where they get physical therapy from therapists. We are trying to change that by developing autonomous, smart robots that can provide physical therapy in any indoor space, even children's homes. Part of the therapy process is for the robots to monitor the arm and leg motions of the children. This process of monitoring motion is known as motion capture. The existing motion capture system that we are using on these robots is based on sensors that are worn over the body, and they're very similar to a magnetic compass. So they are very similar to a magnetic compass, and they're sensitive to the Earth's magnetic field. So this type of technology is an industry standard, and it usually works flawlessly. But there's one little limitation. If there are large metal objects or electrical mains wiring nearby, that causes electromagnetic interference. This electromagnetic interference throws off the magnetic sensors. This throws off the motion capture system, and that causes the robot to malfunction. Now, this is a big problem because this really limits where we can use these robots for physical therapy. My thesis is about finding a solution to this problem. And my solution is a new motion capture system that does not use magnetic fields. Instead, it uses a special black and white marker and a camera, and these markers are worn over the body. I'm sure everybody is familiar with how barcodes and QR codes work. So these black and white markers work in a similar way. By using a specially designed bracelet with these markers printed around the circumference, using a camera, we can track the motion of any body part in 3D, any body part that is wearing these bracelets. Part of my thesis is also determining the accuracy of this system in terms of different variables like camera resolution, baby size, distance from the camera, and so on. So this is my thesis. It's about developing a treatment for a condition that affects about 17 million people. And I am not developing the treatment, but I'm developing part of the technology that is used to deliver this treatment. Thank you.